Let us now discuss resultant of force systems. So, um, we have also, or I have also mentioned that for a resultant of force systems, for a concurrent force system. So when you say concurrent, this is just a recap, by the way. When you say concurrent force systems, the line of action of all of the force vectors has one common intersection point. Okay, so say you have this force and then this one, then here. Okay, say for example, if the lines of action of all of the forces in a system intersect at only one common point, then it is called a concurrent system. For a concurrent force system, always that the resultant is just a summation of all the force vectors. Okay, but what if it's not concurrent? So generally, some of the force systems are concurrent, some are non-concurrent. So let's make it more general. What if we consider that all of the force system, I mean in a certain force system, the force system is non-concurrent. So even if I extended the lines of action of these three forces, say in this system, they intersect on more than one intersection point, and with that case, it's non-concurrent. So we could not just simply add all of the force vectors and say that that's it, that's the resultant or the equivalent system. Rather, we what we do is we first transfer it to a common point. So say we are going to transfer all of their points of action on one common point, say point O. Okay, so what happens is that it is transformed to this one. So as you can see, the points of action of the three force systems are all transferred to point O. This makes the system concurrent. But remember, every time you transfer the point of action of a force to another point aside from its line of action, there is always a couple of transfer formed. So when we transferred F1 from this point of action to point O, it's now here, but there is a couple of transfer forms. Say we call that a CT1. Okay, and for F2 we transfer it from this line of action to this line of action involving O. There is also another couple of transfer form, and we call that CT sub 2. And for F3, we transfer it here. There's also another couple of transfer form. We call that CT3. Okay, so this force system is equivalent to this force system. What we did is that we make this non-concurrent force system a concurrent one. But since we transferred them into a single point, there are couple of transfers formed. Okay, so therefore we have reduced this force system into a force couple system. Okay, and with this, for the resultant of this force system, for all of the forces in the system, we get its resultant, and for all of the couples or couple moments in the system, we also get its resultant. So therefore, the resultant of a force system is defined to be the simplest system that can replace the original system without changing its external effect on the rigid body. So generally, if we have a non-concurrent force system, we transfer it we transfer everything to a common point to make it concurrent. But with that transfer, there every time that the force is transferred from one point to another point, aside from its original line of action, there is always a couple of transfer formed. And to get the resultant, of course, we get the resultant force by adding all of the force vectors in the system to make it a singular force. It's always the definition of the resultant. From a lot of vectors, we convert it into singular equivalent vector that has the same effect on the rigid body. The same as with the couple vectors, we also get its couple, what we call the couple resultant, wherein we add all of the couple vectors. So this is now the resultant of this system. We have a resultant force and a resultant couple acting at a certain point. Okay, so for a general system, okay, uh, if we make generally all of the force systems are transferred to the origin of the system. So with that transfer, of course, the resultant force is just definitely the summation of all of the force vectors. But since there are transfers that are made, couple of transfers existed, and the resultant of all of the couples or couple vectors, we just add all of the couple of transfers. And if there are other couple vectors existing originally on that system, we also add it to the couple of transfers. So it's actually a summation of all moments about point O, since we transfer everything at the origin. So basically the resultant couple is just a summation of moments about the origin. Okay, so for a three-dimensional system, x components of resultant force R is simply summation of all x components of all the forces in the system. Same for y and for z component. Now for the resultant couple, x components is simply summation of all moments along moment vectors along the x-axis. For the y component, summation of all moments along moment vectors along the y-axis, and also for z. But for two-dimensional, we only have force. If two-dimensional, automatically or commonly, we consider the plane system as an xy plane. So we only have x and y components for the resultant force, and simply summation of x components and y components respectively. And also for there is no longer a z component of the resultant, since it's two-dimensional. It only acts on the xy plane. But what we could have is the resultant couple. Okay, so we just sum up all of the moments at a certain point, and usually at the origin. And automatically, since the rotation is all acting at the xy plane, the couple vectors formed will just will be acting along the perpendicular to that plane, which is the z-axis. So that would be perpendicular to this paper or to this plane of yx. Okay, if we have say a parallel coplanar force system. So when you say parallel, of course, when forces are parallel to each other, that means even if you extensively elongate their lines of action, they will never intersect. Coplanar meaning they all lie on the same plane. So in this case, they all lie on the same plane, xy plane. Okay, so to reduce this into an equivalent force couple system, generally or commonly, we transfer all of its points of action to the origin, because the origin is most commonly the most convenient point to transfer to, or the most convenient transfer point. So if we already transferred everything here, for example, Then for every transfer of a force, there is always a couple of transfer formed. So there will be a couple of transfer for F1, for F2, and for F3. So with that, if everything is now at the origin, we could simply convert it into a resultant force or a single equivalent force simply by summing up all of the forces. And for the couple resultant, we simply sum up all of the moments of each of the force systems about point O. Remember, okay, if we remember that the couple of transfer is equal to the moment of the force about the transfer point. So if we are going to transfer F1 to the origin, okay, the couple of transfer formed would be F1 times x1, since x1 is the perpendicular distance from the transfer point to F1. Okay, same with F2 and F3, such that the couple resultant is simply we simply add all of the moments of the forces about point O, because their moments about point O is their couples of transfer formed, since we are going to transfer everything to point O. Okay, so this is now the equivalent force couple system. Now, we could also actually get the resultant force system. Okay, so this is now the resultant force system. And as you can see in this resultant force system, since the system only involves a force, you could not see any couple vector here. Unlike here, okay, couple vector was formed because we transferred everything to a single point, the origin. So there is, of course, a couple of transfer. Okay, so we get the resultant force equivalent or resultant force couple system. Now in here, this is only a resultant force system because as you can see, there is no longer a couple vector. How did it happen? Okay, what happened is we just reversed engineered the changing of line of action of a force. Now remember, if you are changing the line of action of a force, say we have this force, if we want to transfer it here, okay, there is always a couple form. Okay, but if we are going to bring it back to its original position, the couple formed will be non-existent. So what happened is, there is this vector r is located at a certain original position. Okay, say this is our force vector r. If we transfer it here, there is a couple vector form, which is in the form of the resultant couple. So if we are going to transfer it back to its original position, the couple of transfer no longer exists. Okay, and we transfer that to a certain distance x, such that if we are going to transfer the resultant force r back to the origin, the couple of transfer formed is this resultant couple. Okay, so therefore resultant couple is equal to r times the distance x, because that is the couple of transfer that will be formed if you're going to transfer r to origin O. Okay, but if we are going to bring it back to its original position, then therefore the distance x is equal to the resultant couple divided by the resultant force. So, ang nangyari dito, para lang nating ni-reverse yung changing of line of action of a force. Para lang yung resultant na makuha natin is just a force system, hindi force couple. So, para mawala itong couple, lipat natin siya such that ma-reverse itong couple dito. Okay, so ito yung result. So, yung distance na ililipatan natin dapat yung distance is pag binalik natin siya dito, yung couple of transfer is equal dito sa resultant couple. Okay? So, technically, summation of MO, which is the coupled resultant, is equal to the resultant R times the distance X, which is the distance of the point of action of the resultant, to make the resultant system just a resultant force system instead of a force coupled system. So there are a lot of types of obtaining the resultant of a force system. You could actually reduce it to a force coupled system or just a force system, like this principle. Okay, so to illustrate the principle further, let's have examples. We'll start with this example. Yeah. So we have here a coplanar force system in the figure consists of 3 forces and 1 couple. So, meron tayong tatlong force, ito, tsaka ito, and then 1 couple vector. Determine the equivalent force couple system with the force acting at point O. So, what will happen is that since ito lahat forces dito sa system or non-concurrent, we make it a concurrent force system by transferring all of the forces into one common point, which is at point O. So expect that since we are going to transfer it to another point, then there are a couple of transfers formed. Okay. Before we proceed answering this example, let's have this general coplanar force system. It's a general principle for this one. Kasi ito coplanar. So, what if hindi siya, rather, ito kasi parallel. So, what if hindi siya parallel? So, we have all these force vectors, F1, F2, F3, all of which is non-concurrent with each other. So, to make it concurrent, commonly, we transfer all of their points of action to the origin. So, pag nandiyan na sa origin, pwede na natin gawing singular force system lahat ng forces. So, that is in the form of the resultant force R, which is equal to, of course, the summation of all the force vectors. And the resultant couple is simply the summation of all the moments about the point O, because all of the moments about the point O are all of the couple of transfers formed when we transfer all of these forces to point O. Okay? Tapos, for us to make this instead of an equivalent force couple system, if we want it to be an equivalent or resultant force system, we have to get rid of this couple resultant. How do we get rid of it? By transferring R, no, yung line of action ng R from here, dito natin ililipat. Hindi dito, kasi dadagdag tayo ng pag dito, madadagdagan yung couple transfer. Pero pag dito natin ililipat yung line of action, mawawala to. So, we are just like doing a reverse engineer with changing the line of action of the force. So, let's say andito na siya to a certain line of action. That the transfer is, it has a perpendicular distance from point O, which is in the form of D. So that, kung ibabalik natin siya dito, let's say, andito na siya, meron siyang couple of transfer na ma-form. And itong couple of transfer na ito, okay, that is equal to the resultant R times the perpendicular distance D, which is simply the moment of the original force about point O. So, equal na siya dito. No, itong couple of transfer, ito yung magiging equal sa couple resultant. Pero para mawala yan, babalik natin siya dito sa original to a certain distance, to a certain perpendicular distance, para lang mawala yung couple of transfer. So, siya ay magiging equivalent or resultant force system. Yeah. So, yun. Okay. There are three possible outcomes when it comes to resultant system. One is if the resultant force is equal to zero, therefore the resultant is just a couple resultant. So there are times that the resultant force is zero, but the resultant couple is not equal to zero. So we just say that the resultant is just a couple resultant. But there are also times that the resultant couple is equal to zero and the resultant of the system is just a resultant force R, which is acting, of course, through the origin. Kasi conveniently, again, to make a non-concurrent force system concurrent, we have to transfer everything conveniently to the origin. Now, third possible outcome is that both is not equal to zero. So when we transferred all of the forces on the origin, there is a resultant force value that is non-zero, and the resultant couple is also not equal to zero. So these are the three possible outcomes. Going back to our example, this is the force system. What the problem wants us to do is to get the resultant or the equivalent force couple system, with the force acting at point O. So, syempre, andito yung origin. So, if we are going to transfer everything here, remember, meron tayong couple vector. So, aside from the couple of transfers that will be formed by transferring the 90 and the 50 Newton forces here, there is one original existing couple vector. So, isasali din natin siya sa resultant couple. Okay? If the question, maybe some of you, there will be a question in your mind that will arise. So if we are going to transfer if we are going to transfer this couple vector to another point, is there a couple of transfer form because we transferred a couple? No. Again, couple vectors are movable. Wherever you transfer a couple vector, it does not form a couple of transfer. So, couple vectors can freely be moved and transferred. Unlike force system, that if you are going to transfer force systems, there will always be couple of transfers formed. But for couple vectors, they are movable without changes on the effect on the rigid body. Okay. So, dahil ito transfer natin lahat ng forces dito sa origin, merong magiging couple of transfer na ma-form. First off, couple of transfer ni 90 Newton load. Say this is our F1. So that the couple of transfer formed when we transfer that to the origin is CT1. That would be simply the moment of F1 about the transfer point. Oh, same with the couple of transfer. We're going to transfer the 50 Newton load at point O. So that is the moment of force. Let's say this dito yung second force vector. Okay, about point O. Ayan. So may dalawang couple of transfers. This third force vector, the 100 Newton force, okay, we don't have to transfer it to the origin because it's already at the origin. So therefore, there are just two couple of transfers that will be formed by transferring F1 to the origin and F2 to the origin. So we'll have to get it first. We'll have CT1. So the moment of force F1 to point O is simply the magnitude and its perpendicular distance. So with the 90 Newton magnitude, the perpendicular distance is simply the 600 millimeter distance. We'll have 90 times 600. Okay. Now, the rotation is clockwise. If you are going to use the right thumb rule, this is the axis perpendicular to the paper towards us is the positive z-axis. So if you're going to use the right thumb rule, right thumb rule tayo, so ito yung right thumb, we point it to the positive z-axis. If the rotation of the hand is an easy curl, then the force vector is along the positive z-axis. So if we rotate our hand such that it will curl easily, then the rotation is anti-clockwise or counterclockwise. So since the rotation of F1 about the origin is clockwise, therefore the couple formed is negative. Okay? So the couple of transfer formed or the moment of the 90 Newton force about point O is clockwise, then therefore the couple of transfer is negative. So we multiply 90 times 600. So 54 will have negative 54,000. Yeah. This is of course in Newton mm because the force is in Newton and the distance is in millimeters. Another one is we are going to transfer the 50 Newton load, F2. So, by principle of moments, since, look at the force vector of 50 Newton. If you're going to extend the line of action, yan, this would be the perpendicular distance. And it would be hard for us to look for this perpendicular distance. So, what we are going to use is that we are going to use its convenient x and y components para madali lang natin makita ang kanilang individual perpendicular distances. Gamitin natin yung varinotes. Okay, so for the x component, we have 50 cosine of 40. Teka, naka-radians pala to. So, it should be in degrees. Ayan, 38.30. So this is 38.30 newtons. And for the vertical side 40, 32.14 newtons. Ayan. So itong 32.14 newtons, ang kanyang perpendicular distance about point O is 800. By the way, recap lang. Baka nakalimutan lang. Moment about a point is equal to force times its perpendicular distance. So, laging perpendicular distance. Ito yung scalar formula ng moment. So, kanyang perpendicular distance is the 800 mm distance. So, the rotation is counterclockwise, meaning it would be positive. So, for second couple of transfer, we start with 32.14. 32.14. Distance is 800. Positive since it's counterclockwise by right thumb rule. But as for the 38.3 component of the 50 Newton force, it would be negative. So 38.3, then the distance is 500. So this is the line of action of the 38.3 Newton. This is the perpendicular distance about point O, and that is 500 mm. So, times 500. Siya naman ay negative because its rotation to point O is clockwise. Question. Paano kung counterclockwise? Pwede naman siyang umikot papuntang origin ng counterclockwise. Okay, the rotation that you have to consider is the rotation where it is wherein the rotation is more convenient. It would easily or more conveniently arrive at that point. So pag counterclockwise, mas malayo siya kontra sa clockwise. So yung rotation niya is clockwise, hindi counterclockwise. So ayan. So let's just add everything. So 32.14 times 800 minus 38.3 times 500. Tama ba to? Okay. 6562 Newton mm. Okay, kasi naka-minus kasi, kaya maliit lang siya. Anyway, so positive. So meaning yung rotation niya ay counterclockwise. Ito naman, therefore its rotation is clockwise. Okay. So again, pag counter, positive. Pag clockwise, negative. Again, right thumb rule. Yeah. Okay. Tapos na tayo sa couple of transfers. Na-transfer na natin yung 90 dito at 50 Newton load dito, producing two couple of transfers. Now, andito na lahat. Kumbaga, ang nangyari, we already have all of the forces are here, yung 90 Newton, tsaka yung 50, tsaka yung, so ito yung F3, ito yung F2, ito yung F1. Okay? Tapos, yung couple vectors, no, yung CT1 na clockwise, at saka yung CT2 na counterclockwise, at saka yung couple vector na to, by the way, wala pa pala siyang magnitude. Lalagyan natin ng magnitude. Hindi pala given. So, let's say this couple vector has a magnitude of, what if we make it 10,000 na lang? Newton mm. Ayan. Okay. So, add na natin. Kuha tayo ng resultant force at resultant couple. So, for the resultant force, we make it an summation of forces. Okay, so for x component, the summation of x components of the forces. So, for the 90 Newton, that's to the right, it would be positive. For the 50 Newton, 38.3 should be also, of course, positive because it's to the right. And for the 100 Newton force, so we have to the left siya, so negative 100, then over 3/5. Yan, no? Kasi for the slope 4:3, yung kanyang hypotenuse is 5. So, ang kanyang horizontal component is 100 times 3 over hypotenuse 5. To 3/5. Ito naman, 100 times 4/5. So, ano lang yan? Trigonometry na yan. Okay? Basic. But anyway. So, we have 90 plus 38.3 plus minus rather 100 3/5. You have 68.3. Okay, yan yung x component ng resultant, yung y component naman ng resultant. Add lang natin lahat ng y components. So, we have for the 90 Newton, it has no y component because it acts directly at the along x-axis. For 50, that's 32.14 since it's upward. Then we consider positive signs for the 100 Newton load since it's downward, so we consider negative. So, we have negative 100 times 4/5. So, yung 32.14 we have negative 47.86 newtons. Ayan. yung ating couple resultant, a-add lang natin lahat. Yung couple na 1,000, so since it's clockwise, negative siya. We consider it as a negative couple. So, negative 10,000. Ito yung C, yung original couple vector C. Let's say, tawagin natin siyang couple vector C. Tapos, dalawang couple of transfer. So, for the 54,000, since it's clockwise, so we treat it also as a negative couple. And then, ito, positive, 6,562. Ayan. Negative 10,000 minus 54,000 tapos plus 6,562. Yan. So, we have negative 57,438. That is, of course, in Newton mm. Yan. So, this is now the resultant force in the resultant couple. As for the resultant force, yung kanyang resultant is Pythagorean lang. We have rx squared plus ry squared, square root of that quantity. So, ayan. 68.3 squared plus 47.86. By the way, di na natin i-take ang negative kasi pag square mo yan, positive pa rin naman. 83.4. Ayan. So, therefore, this force system is equivalent to this force system. Ayan. Meron tayong x and y axis. Tapos, yung resultant natin dito, since yung kanyang y component ay negative, tapos ang x component ay positive, so ito yung kanyang x component, ito yung kanyang y component. So, yung resultant natin acts at this quadrant, fourth quadrant, wherein it's equal to 83.4 newtons. Tapos, ang ating couple ay negative. So, therefore, it's clockwise. This is the couple resultant, 57,438 Newton mm. Yan. So, we have already, for this original force system, we have determined its equivalent force couple system. The resultant force is 83.4 Newton in magnitude. But as for its x and y components, 68.3 and negative 47.86 x and y components, and for the couple resultant, 57,438 Newton mm clockwise. Yan. Okay. So, we're going to proceed to the next example. Okay. This is another force system. It's acting on a structural member, consists of couple C. So, ito yung structural member natin. It's like a bar. It's like a prismatic bar. Tapos, with this prismatic bar, there are forces acting on it and also a couple moment acting on it. Ayan. So, ito yung couple C. Bigyan lang natin ng pangalan. It's the couple vector C. Ayan. And then, yung forces F1, F2, and F3 acting on it. So, we're going to determine the equivalent force couple system with the force acting at point G. So, you have to transfer all of the forces at point G. And the magnitudes of these forces are here. So, just refer it later. So, what the problem wants is for us to transfer all of the forces at point G to make it concurrent. And then we get the resultant force couple system. So, what will happen since we are going to transfer F1 to point G? So, we may use our position vector r from the transfer point to any point of action of F1. Ngayon, this is what we are going to use for couple of transfer produced by transferring F1 from point B to G. Now, since they have a common point of action, both F1 and F2, then we could also use this for couple of transfer of F2 as well. Okay, and as for F3, since it's already acting at point G, then we don't have to transfer it, so no couple of transfer for it. So with this, we'll have couple of transfer of 1 and 2, force 1 and force 2. Okay, we'll have R cross F1 plus R cross F2. Good thing here is that both the F1 and F2 have the same position vector, so we could just actually factor out the position vector R. We have G to B, then times force vector 1 plus force vector 2. Okay, rather cross. We'll use cross product. So unahin muna natin kunin ang force vector ni 1 at saka ni 2. Okay, we'll make it faster. F1 will have 100. Then for the lambda, we use distance from A to B. So A to B, x component is 4 meters, negative. So we'll have negative 4i. And as for the y component, we'll have this one 6. So since papunta doon, negative 6j. Then for k, upward, this distance, this is 3 meters. So positive 3k. Let's check kung tama ba. So we have 4, negative 6, positive. And then we have 4 squared plus 6 squared plus 3 squared. We love it. Muna tayo. We have square root of, we have 4 squared, 6 squared, 6 squared, 3 squared. Okay, 4 squared, 6 squared, 3 squared. So we'll start off with negative 4. What's the value of x here? No, negative 4. We have negative 52.21 I, 51.21 I hat. And then we have negative 6. Negative 76.82 J hat. Tapos yung K hat, teka lang, 3. 38.41 K hat. Ayan. Anyway, for F2, ano yung ano ng F2? So since F2 is acting directly along x-axis, so yung 90, yan na yung I hat. Since positive siya along positive x-axis, so we have 90 I hat. That's for F2. For F3, it's directly acting along positive y axis, so we'll have 120 J hat. Alright. So for the result for F1 plus F2 vector, so we'll have negative 51.21 plus 90. $38.79 I had. Tapos, negative 76.82 J hat plus 38.41 K hat. Yan. We will be using this for their couple of, ito na yung total couple of transfer ng dalawa. This is already 4 couple of transfer of force 1 and force 2. So if I, J, and K. So, ano yung RGB natin? G to B. So, from G to B, yung X component niya is negative 4I. And then, G to B, then we have for Z-axis positive 3K hat. This is in meters. Sorry, meters. Yeah. 4, negative 4, positive 3. Okay, just checking. Negative 4, 0, positive 3. And for F1 plus F2 vector, it's this one. 38.79 positive. For J hat, negative 76.82. For K hat, 38.41. So, yung ating couple of transfer for F1 and F2. So for I hat 0, for J hat 3 times 38.79. 3 times 38.79. 116. Paki-check na lang sa calculators ninyo. J hat. For K hat, negative 4 times negative 76.82. Negative 4 times negative 76.82. 307.28 K hat. Okay yun. Tapos, paakyat 0, tapos ito, negative times negative maging positive. So, 76.82 times 3. That would be 230.46. Tapos, multiply dito siya sa I. So, I hat. Okay, last, 38.41 times negative 4 times negative 1, it becomes positive. 38.41 times negative times 4. 38.41 times 4. 51. J hat. 153.64. So, plus 153.64 K hat. Rather, J hat pala, hindi pala K hat. Teka lang ha. So, this is K hat 0 for I hat, and this one for J hat. So, it would be positive J hat. Ayan. So, i-add lang natin lahat ng I hat, J hat, at K hat. So, yung couple of transfer, dito lang natin isusulat. Couple of transfer ng force 1 at force 2 ay, for I hat, we only have 230.46. For J hat, we have 116.37. Then plus 153.64. 116.37. 270.01. That's for J hat, and for K hat, isa lang, we have 307.28. K hat. So, since yung ating R is meters, ating F ay Newton. So, this is in Newton meters. Ayan. So, we also have the couple vector C. We'll have to get its vector notation. It's magnitude is 200 Newton meters. So, we have 200, and we'll have to use the unit vector from, okay, right thumb rule. We will be pointing from G to B, but when we are going to follow the rotation of this couple vector C, I'll have a hard curl of my hand. So, actually, the couple vector is from B to G. Because if we will point from B to G, tapos following this rotation, I'll have an easy curl of my hand. So, therefore, the force vector is actually towards G, from B to G. So we'll have to use the unit vector from B to G. Okay, so I have 200. So from B to G, we'll have for x, that's 4i. Then we have minus 3k hat. Walang j. Okay, so this is over 5 because square root of 4 squared plus 3 squared is 5. So we'll have 200 times 4 over 5. That's 160 I hat. Then for j hat, k hat rather, that's 200 times 3 divided by 5. That's 120 k hat. So this is for the couple vector C. The vector notation is this one. So we could now have, we no longer have a space, but alright. Okay, for R, we'll just sum up all of the force vectors. So we'll just do it directly. So we already have F1 plus F2. So this one is what we will use to add to F3. So we'll just copy, since F3 only has J hat, doesn't have I and K hat. So we'll have the same for I hat, K hat. That's F1, F2. 38.79 I hat. For J hat, we'll have to add 120 minus negative 76.82. That's 43.18 J hat. And for K hat, we only have 138.41. This is the resultant force. For the resultant couple, we have to add everything. We have to add this total couple of transfer and the existing couple vector. So for I hat, we have to add 230.46 plus 160. That is 390.46. I hat. For J hat, we'll add, wala tayong i-add dito, so 270.01 lang agad. J hat. And as for K hat, 307.28. K minus 120. 187.28. 187.28 K hat. So ito yung couple resultant. This is in Newton meter. Ayan. Okay, tapos na tayo. So for the equivalent force couple system, the resultant force is 38.79 I hat plus 43.18 J hat plus 38.41 K hat. This is in newtons. As for the couple resultant vector, we have 390.46 I hat. For J hat, 270.01 J hat. For K hat, 187.28 K hat. This is in Newton meters. So this is the equivalent force couple system of this given force system. Next example, for this given figure, we are going to determine the resultant force couple system acting on the beam at point A. So what will happen is we have to transfer all of the forces at point A. Okay? And then we'll get the resultant force couple system. Now, as you can observe in this system, we have one couple vector. This 1,000 pound force and this 1,000 pound force. They have parallel line of action and both are opposite in direction, so they form a couple. So let us say we'll have your couple C that is 1,000 times 4.5 since they have perpendicular distance of 4.5. So the couple vector of these two couple is 4,500 pounds-foot clockwise in rotation. Okay, so the one that we will just transfer is the 1,200 pounds force here and the 600 pound force to point A, such that couple resultant is, we'll add the couple vector C plus the total moment about the transfer point A, because this one is the total couple of transfer for both the 1,000 pound force and the 600 pound force. We no longer have to transfer these two because they form a couple, so we'll just consider their couple moment formed. So by the way, since this is clockwise, remember with right thumb rule, negative, this is positive. So for this one, this is in sign convention, this is negative moment or couple. And then for 600, it's moment about point A. The rotation is counterclockwise, so that would be positive, and then we have force times perpendicular distance 8.2 plus 5.5. So this one, this 5.5 plus 8.2, that is its total perpendicular distance. As for the 1,200 pound force, the rotation about point A is clockwise, so the couple of transfer is negative, or the moment about point is negative. We have the force 1,200 times the perpendicular distance 8.2 about point A. This is now your couple resultant. We'll add everything. Okay, negative 4,500 plus 600, 8.2 plus 5.5. Okay, and then 1,200 negative 1,200, then the distance is 8.2. Okay, negative 6,120. This is in pounds-foot. That's now your couple resultant. So what we did is that we just directly added everything. Not unlike in our previous examples, we individually got the couple of transfers. Okay. Now for the resultant force, kasi we need the resultant force couple system. So we already got the resultant couple. We need the resultant force. So as for the resultant force, just sum up all of the forces. So in this case, we only have y components of the resultant force. We have for the 600 and 1,200. So we have positive for 600 because it's upward, negative over 1,200 because it's downward. So we have negative 600 pounds. Okay, so to like equivalent couple system wherein all of the forces act at point A, this is now the result. So you have the resultant force downward, resultant force, it's downward. Okay, since wala namang y component, so x component, so y component lang, so ito lang siya, 600 pounds. Tapos ang resultant couple ay negative. Since this is negative, it's acting clockwise with a magnitude of 6,120 pounds-foot. Tapos ito yung resultant couple. So, bali, ito na rin yung resultant niya. Okay. Resultant force. Okay, so this force system is equivalent to this force system. Remember, this is point A. Okay. Yan. So, na-transfer natin lahat sa point A. Okay, that is for A. This is for A. But what if we have to determine the resultant force system only? Okay? So, para force lang yung matira, itong resultant force lipat natin siya to a certain distance to negate this coupled resultant. Okay? So, the question is, should we move it to the right or should we move it to the left? The answer would be, we have to move it to the right, because if we will transfer it back to A, its moment to A, if it is originally here at the right side, then the couple of transfer will be clockwise rotation. So we really have to transfer it to the right side. Okay, now this is the equivalent force system. Sorry, this is point A. Okay, so we'll transfer the 600-pound force here. Ayan. But what is the distance? At what distance should we transfer it to get rid of the couple resultant? So, couple resultant is equal to 600 times x. So, x, therefore, couple resultant is 6,120 over 600. And therefore, x is equal to 6,120 divided by 600. We have to move it by 10.2 feet. Ayan. Okay? Because, pag ibalik natin yung 600-pound resultant force dito sa A, what will happen is, we have it here, then we have to form a couple of transfer, which is this one. And this couple of transfer should be equal to the resultant couple, which is equal to 6,100. Okay? So, parang ni-reverse lang natin ang changing of line of action of a force. So, this is now the answer for letter B. This is now the resultant force system only. So, the resultant should be located here at a distance 10.2 feet from A. Yan. So, this is the equal resultant force system. This is the equivalent force couple system. Yan. So, kasi pag resultant force system, then we have to provide the location. So, yung location niya from point A is, yan, 10.2. Okay, that's it. We'll have part 2 on our next video.